Good morning, students. I am Professor Shalini Sahai from Department of Electronics and Communication, uploading my lab video on signal and system. This is the list of experiment. 10 experiments are there which are based on the Matlab program. Today we are going to discuss the sixth experiment to find linear convolution of two continuous time signals, and we will plot the result. Before starting the practical, we will discuss the theory about the practical. In mathematics, in particular function analysis, convolution is a mathematical operation on two functions f and g, producing a third function that is typically viewed as a modified version of one of the original functions. So it represents the area overlap between the two functions as a function of the amount that one of the original function is translated. It's a form of cross correlation, and it has very wide applications which includes probability, statistics, computer vision, image and signal processing, and various differential equations. Now the convolution of f and g is written as f star g using an asterisk or a star sign. It is defined as the integral of the product of the two functions after one is reversed and shifted. As such, it is particular a kind of integral transform. Mathematically, convolution is defined by the function which follows the property of commutative. Now we will start discussing its Matlab code. Now we have small t, that is starts from 0. हमने put the interval bit of 0.01 and up to 10. x1 is equals to cos t, and x2 is the second signal which is represented by 2 into star t. Now we will first plot these two signals independently. We will use the command subplot. 3 means we have divided the figure window into 3 rows, 1 column, and its first figure is plotting t on the time axis, and x1 is the input signal. We will label the x label, y label, and we will give the title as first signal or the sequence. Now we will subplot the second figure of the third row in the first column, and we will plot t comma x2. We will label x label and y label. Now we will give the title as second sequence. Now y is equals to convolution x1 comma x2. Now this is the mathematical function which is already stored in the Matlab. Now n3 is the length y. Now t1 we defined as 0 to 1, and it tends to n3 minus 1. Now we will plot the signal subplot 3 comma 1 comma 3, and we will plot t1 comma y, and we will x limit from 0 to 600. Now we will label x label and y label, and we will provide the title as convolution of the two sequence. After running this Matlab code, we will have the following simulation result in the figure window. First figure which will represent the first signal. This is the second. First it is the cos signal, second it is a ramp signal, and third one represents the convolution of the two signals. In this way we have plotted the convolution of the two continuous time signal. Thank you.